Welcome, my dear J26 students. The next chapter is here after the big unit of electromagnetism, right from electrostatics to magnetism. We are now on to the optics part. And yes, why not start with ray optics? A big chapter, conceptual chapter, tricky chapter, but also scoring. So all sorts of questions can come right from simple to hard question. And of course, in JEE Advanced, the good level questions always come from ray optics, you will see. So let's begin with this chapter. And today, I am dedicating completely for plane mirrors and reflection. Now, you might see that if you open up maybe NCRT or something, and probably just see some basic stuff on plane mirrors, but the questions on plane mirrors can be of variety in nature, right from field of view, the size of the mirror needed, mirrors at an angle, deviation, the concept of the images being formed. So many things are there just in plane mirrors. So today's session purely dedicated for plane mirrors. Next session will be for curved, basically concave and convex mirrors. Is that right? So welcome aboard, everyone. Hi Madhura, Jayashree, Sangam, welcome Bhargav, welcome Muturaj. Hi Josh. All right. Welcome, Joe. Welcome everyone out there. I hope you guys are ready, geared up for this particular class. We'll start right from the basics. This is me, your Captain Shreyas. Been teaching, guiding kids for the past 13 plus years, producing the top ranks, sending the kids in their dream desired colleges, be it IITs, be it NITs, be it BITs, be it triple ITs. You'll always find hundreds of kids out there who have been nurtured, guided, mentored by me. So I did my BTech from NIT Nagpur, did my research from IIT Bombay, and been there doing that for just all of you. So get set, go, subscribe to the channel, and also like this video. And if you have not yet registered for MVSAT, now is a good time you do that because the exam is just around the horizon. Yeah, 4th of October, first date, 5th, 11th, and 12th October. Lots of prizes to be won, lots of scholarships there, and of course, lots of freebies the moment you register for MVSAT. And if you're wondering where to register from, the link is there down in the description box and do it right away, right now. All right. So let's begin with the concept of reflection and refraction. Okay. This session will be around 1.5 hours, right? Hi, Jayashree. Welcome. Hi, Rahul. Yep. Hi, Geetika. Hi, Adarsh. Hi, Akshaya. Hi, Sangam. Welcome. Good evening. William, there will be many lectures on this. Just reflection, 2 lectures, refraction, around 2 classes, lenses are there, combination is there, prism is there. So you can see good 6 classes, I think, will be bare minimum. All right. Okay. Welcome, Harshan. You're from class 10th. I hope you will be able to understand things, whatever I'm going to teach today. Okay. But yeah, there are a lot of 9th standard kids, so I'm guessing you will be able to do it. Now, in this chapter, the main concept is finding images, locating where should the object be so that the image is formed this way, what kind of image is formed, which kind of lens, which kind of mirror are you using, how much size will you need, what is the radius, what is the size. All these sorts of questions usually come from this chapter. Now, when we talk about, any light which is falling on a surface, it can undergo one of these 3 things, but we'll ignore the third one for now. It can, number one, get reflected. Okay, that means it will bounce off the surface, that is reflection. Second thing which can happen is it can pass through that surface like glass or quartz crystal or water. The light will enter and pass through that surface. That is the second option. And the third option is it will get absorbed by it. Let's ignore absorption for now because we are just talking about what will happen to the light after that event of reflection or refraction. Absorption, it's okay, it's disappeared, it's absorbed as energy. That's the third one. So whenever light gets transmitted, that is called refraction. When it bounces off, it is called reflection. So light getting, refraction means it is getting transmitted. It is transmitting to other medium. It is transmitting to some kind of other medium. There are separate lectures dedicated for just refraction. And when I talk about reflection, it is bouncing off. It is bouncing off in the same medium. That's very important. In the same medium. In the same medium. When it does so, when the light bounces back in the same medium, couple of things will obviously remain the same. So the speed of light, the speed of light, its frequency, its frequency and wavelength. All of this remain unchanged. All of this remain unchanged. They remain basically the same. Refraction, things can change. So for now, reflection, understand, nothing will change. If it came with 3 lakh kilometers per second, it will bounce off at 3 lakh kilometers per second. If the frequency was 10 kilohertz, the frequency of reflection will also be 10 kilohertz. If the wavelength was 5 nanometers, reflected wavelength will also be 5 nanometers. Keep this in mind. Okay. But in refraction, things will change. We'll discuss it in a separate class. Now, there are some rules which you should know for any kind of reflection. But before going there, see, whatever laws we are going to study is for a flat surface. But please mind it that you can apply it for any kind of curved surface. Like for example, imagine I have a surface which is curved like this. I have a surface which is basically curved like this. Now, usually when you see such a diagram, wherever you see these small lines, that is the part which has been basically silvered. This is the part which has been silvered. Now, whenever they say silvered, means silver surface is like a reflecting surface. So, the other side, okay, this part, if it is silvered, this is the reflecting surface. This is where the surface is reflecting in nature. So the silvered surface will be the back part of the mirror, and the reflecting part will be obviously the front part of the mirror. The front part of the mirror. So whenever any ray will come, it will get reflected like this. If a ray will come like this, it will get reflected from here. If a ray will come here, it will get reflected like this. So this is how the reflection will happen on the front surface, which is the reflecting surface. This part, silvered surface, nothing will happen. If a ray will fall, it's behind the mirror. So behind the mirror, nothing will happen. We'll probably see something being painted on it or some coating on it. Okay. So that is something which you should know. Although it is a curved mirror, any part of that curved mirror, if I take any particular part, okay, if I take of that particular curved mirror, you will see at the end of the day, it is nothing but a kind of a flat mirror. It's kind of a flat mirror, and you have a ray which is falling onto it, and you have a ray which is reflecting from it. You have a ray which is reflecting from it. The ray which falls onto it is called as the incident ray. It is called as the incident ray. Ray has a direction. Line does not have a direction. So ray is always with an arrow mark. And this is obviously then called as your reflected ray. This is then called as your reflected ray. Okay, everybody with me? Now, if you draw a perpendicular to that part which is being acting like a mirror, if you draw perpendicular to it, that perpendicular is then called as the normal to the surface. Then it is called normal to the surface. So this diagram is applicable not just for flat plane mirrors, but also for curved mirrors, because any curvature, I can take it as small flat surfaces arranged sequentially one after the other to form that beautiful curve out there. So I take a small part and I see the incident and the reflected, and then the perpendicular, which is the normal drawn to that particular surface. Absolutely clear till this point? Okay. Very good. Okay. Yes. Perfect. Sir, is JEE preparation causing hair fall? Yes, definitely it can cause hair fall. So for that, what you can do is you can add some KMNO4 and some H2SO4. Okay. So when you add KMNO4, H2SO4, some nice reactions will form, acidic reactions. Okay, and you can probably see some kind of hair growth. Okay, just maybe. Okay. Anyways, coming back now to the first and the second law of reflection. Very simple. You might have already studied this back in 9th or 10th grade also. I just will reiterate that fact. If you have the incident ray, if you have the reflected ray, and if you draw a perpendicular to it, then the angle which is between the incident and the perpendicular drawn is called as the incident angle, and the angle between the perpendicular and the reflected ray is called the angle of reflection. You will see that the angle of incidence is equal to the angle of reflection. So the angle of incidence equals the angle of reflection. Always, if you increase the incident angle, reflected angle will increase. If you decrease the incident angle, reflected angle will increase. So it is obviously like this. This is the first law which you should know. And the second law, you might have guessed it right in this diagram. Can you see a slightly shaded like sheet or a film over here? You can probably see some slightly shaded film over here. It's a three-dimensional diagram. You will see the incident ray, the reflected ray, and the perpendicular drawn. They are in the same plane of the figure. It will never happen that the incident ray is here, normal is here, reflected is coming somewhere weird direction. Or normal is here, incident ray came from that plane, reflected is in this plane. No, you'll always see that they are going to be coplanar in nature. So this is also very important. This was the first law. So incident, the normal, and the reflected rays are coplanar. This is also a very important law. Keep this in mind. Now we then define something called as the angle of deviation. From this, we also define something called as the angle of deviation. Now, what is the meaning of deviation? You were preparing for IIT JEE. You were preparing for IIT JEE. But then you got carried away, backlogs came in, you got demotivated in the mock test, and slowly you went off to some random private college. That is deviation. Your intended path was IIT, but you got deviated to some other random college. So that is deviation. Same way, this incident ray wanted to go like this. So want versus or reality versus the actual. It wanted to go like this. Is that right? This particular ray wanted to go like this. But as you can see over here, it has turned by this much particular amount. So this delta is called as the angle of deviation. Angle of deviation. Is that right? Can we measure this angle of deviation? Why not? So this particular delta, this I and this R, all three of them together will sum up to 180 degrees. So delta plus I plus R is nothing but 180 degrees. So therefore, delta will be 180 minus I minus R. Therefore, 1 second over here, guys, I and R are equal. That was exactly the first law of reflection. So I and R were equal. So I minus I 2 times. So it will be nothing but 180 minus 2 times of I. So that is the formula for the angle of deviation. That is the formula for angle of deviation. Everybody with me? Very simple, straightforward. Pakka? So two things you learned over here, laws of reflection, I is equal to R. And the second thing, incident, normal and the reflected rays are coplanar and the deviation angle is 180 degrees minus 2I. Amazing. Perfecto. Now let's do some questions coming up on your screen. And here is the first question which is there. Okay. Find what will be incident ray cross producted with reflected ray, and then dot producted with the normal ray equal to. Okay, assuming these are all unit vectors in that direction. So let's use unit vectors, incident unit vector, or else the magnitude can be anything there. So option A, I will tell you, is 0. Option B, I will tell you, is 1. Option C, I will tell you, is 0.5. And option D, I will tell you, is -1. Okay, let's see if we can figure this particular question out over here. What is the answer to this vector equation? I represents incident vector's unit notation. R represents reflected unit vector. N represents normal unit vector in that reflection scenario. Harshan saying 0. Robin saying 1. All right, let's see. Yeah, Sadvik, I'll be sending you the notes, the PDF after the session is over in a day. You will see the link downloadable from our server. All right, in the description box as well as in the comment section, it will be pinned. Okay, like you can see in the previous lectures. I'll tell you what, remember one thing, that incident ray, reflected ray, and the normal ray, by the laws of reflection, are coplanar and are coplanar. And whenever vectors are coplanar, their scalar triple product is always going to be 0. This is a scalar triple product, if you noticed. Why is it a triple product? Because there are 3 vectors. Triple. Double product means just A cross B or A dot B. Triple product means 3 vectors have to be multiplied. Why is it scalar? Because the final outcome is a scalar. When you do cross of this, it will be a vector, but a vector dot a vector will be a scalar. If this dot was replaced with a cross, then the final outcome will be a vector. Then this will be called vector triple product. So the scalar triple product will be absolutely 0. Option A is the right answer. Is that okay, everyone? Got it? So if you have not yet watched vectors or completed vectors in mathematics, don't worry, you will eventually learn that particular property in mathematics. But this is a very basic, standard, well-known property if any kid has studied vectors chapter in mathematics 12th standard. Okay, or maybe some of you might be studying it in 11th. All right, moving on to the next question coming up on your screen. Here it is. If a ray is incident making 40 degrees with a mirror, find the angle of deviation and angle of reflection, both. Find the angle of deviation and the angle of reflection. Let's see how many of you are quickly able to solve this. It will not take you more than 15 to 20 seconds. It's very simple, direct question, but chances of silly mistakes are very, very high. That's the reason why I gave you this question. All right, 140. Okay, let's have a look at it. So first part, let's find the angle of reflection because it is very laddu question then. Okay, if you think about this particular mirror and this is that particular normal, then the ray is coming like this and getting reflected like this. It is clearly mentioned the ray is making 40 degrees with the mirror. That means this angle is 40 degrees. That means this angle is going to be 50 degrees. And this is the angle of incidence. So guys, lot of students would have made this particular mistake, and this will be the angle of reflection. So as you can see, angle of reflection is not 40, it is 50 degrees. How many of you made that mistake? I can see a lot of people putting 40 in the answer. So that is wrong. Got it? So read the question carefully. Always the angle of incidence is measured with the normal, but what is given? 40 degrees with the mirror. This is the mirror, 40 degrees with the mirror. Read the question. Got it, everyone? Okay, now doing the second part is easy because delta is 180 minus 2 times of I. So it will be 180 minus 2 multiplied by incident angle. Incident angle is 50 degrees. Okay, so 2 into 50 is 100, 180 minus 100 is nothing but 80 degrees. So angle of deviation is 80 degrees. So this ray has deviated, it has returned by 80 degrees. Perfect. Amazing. Cool. Let's go to the next question coming up on your screen. And this is also a vector question. This was asked in JEE. The incident, reflected, and the normal drawn are represented by vector A, vector B, and vector C respectively. Choose the correct relation for these particular vectors. Incident ray, reflected ray, and the outward drawn normal. Okay. So let us show this particular diagram now. This is the mirror. Okay. And let's say this is the normal drawn over here like this. And the incident ray will come like this. And the reflected ray will go like this. Okay. Incident ray is basically vector A bar. A reflected ray is B bar. Reflected ray is B bar. And the normal ray and the outward drawn normal is basically C bar. Okay. So question is, can you figure out the correct relation between them? Okay, vector equation is there between incident normal. This is also the vector equation for incident normal and reflected ray. Okay. I feel maybe we'll have to do by the laws of reflection. I don't see any other option with me. So let's assume this as angle theta. This will be also angle theta. As you can see, this vector A will have two components. One component will be like this, and the other component will be like this. These are all unit vectors, mind that. Okay. So total magnitude should be 1. So if you think about it, magnitude wise it is 1. So this particular thing, when I divide, if this is theta, obviously this is also going to be theta only. This is also going to be theta. So this will be cos theta. So it will be A cos theta, but A is 1. So it will just be cos theta then, because the value of A is 1. And this will be nothing but A sin theta, which means it will just be equal to sin theta. Same way I can, split up B into two parts. The vertical component will be B cos theta, but B magnitude is 1, so it will be cos theta. The horizontal one will be B sin theta, but B is 1, so it will just be sin theta over here. So if you ask me, on the left hand side we have B vector. So B vector, what is B vector exactly on the left hand side? B vector, as you can see, it has some horizontal component which is sin theta. So it will be sin theta I cap, plus it has some vertical component which is cos theta. So cos theta j cap. Cos theta j cap. This is basically my left hand side. Somehow my right hand side should be equal to this. Now, will option A give me that? Just think about it, because vector A is something sin theta cos theta. There is some j cap over there with C. I don't think so, because observe carefully, this C vector will be just purely j cap. So I don't think this or even this will give. By the look of it only, it is not going to be true, guys. I mean, just think, how will that just pure j cap get cancelled? Because I don't see it getting cancelled otherwise. Okay, maybe I don't think it will be 1, 2, or 4. I'm guessing. By the look of it, it should be 3. We'll verify it. If I'm wrong, we'll check out some other options. Okay, let's check out the RHS now. Let's check out the right hand side. And the right hand side is this one, which is vector A bar minus 2 times of A bar dot C bar times of C bar. So what is A vector? A vector, as you can see, is this one, which is sin theta I cap minus, this is cos theta j cap, cos theta j cap, okay, j cap, minus 2 times A dot C. Okay, first let's me put A vector over here, which is again the same thing, sin theta I cap minus cos theta j cap, dot producted with C vector. C vector is j cap. Okay, this times of j cap. C vector is outside. Okay, now see what will happen to this. When you do the dot product of this with this, I cap has nothing to multiply, only this will multiply. So we will have over here sine theta I cap minus cos theta j cap minus 2 times. Inside, when you do the dot product, I cap will not multiply, only this will multiply. So it will be minus j into j is 1, cos theta with negative sign will be there. And we will have j cap over here. Minus minus will become plus. So it will become sine theta I cap minus cos theta j cap plus 2 cos theta j cap. Minus 1 plus 2 will become plus 1. So it will become sine theta I cap plus cos theta j cap. Can you see it is exactly this? LHS and RHS are equal. So it should be option labeled 3. Perfect. Option labeled 3 is the right answer. Everybody with me? How we got it? So you have to do some guesswork, or else how many things will you keep on checking, right? A, B, C, D. We cannot check all of them. So sometimes you have to use your common sense and think which option is the best option to cross verify. If it didn't work, then I would have checked the other options then. Okay. All right. All right. So don't worry, we will come to UVF values in curved mirrors very soon in the next class. Okay. Don't worry about it. Perfect. Ready for a killer question, guys? Are you ready for a killer question? Smash the like button in the video right away, right now. A killer question is coming in front of you right away, right now, guys. And here it is. There are two mirrors inclined at some angle. Okay, there are two mirrors which are inclined at some angle. This is, let's say, mirror 1. This is, let's say, mirror labeled 2. What happens now is a ray which comes from somewhere, hits the mirror 1 somewhere, reflects from that mirror number 1, but is then falling onto mirror number 2, and then again reflects over here like this. So this is two reflections which are happening, reflection 1 and then reflection 2. Okay, is that clear? Question is, we have to find what is the total deviation. Total deviation is asked. The total deviation is asked. It's a killer question, guys. Let's see how many of you can do it. Okay. You'll be like, sir, wait a minute. You did not even give us the angle of incidence. Absolutely right. I did not give it. Maybe it will not matter what that I is. And if it does not matter on the angle of incidence, maybe that's the reason why it is a killer question. Got it? Let's do. Let's do. Samla, whenever that MVSAT examination online, if it happens, we'll let you know. But for as of now, 4th, 5th, 11th, 12th are the offline dates in your nearest centers. Now, I'll tell you what. Maybe we should do some kind of a geometrical construction, assume few variables and then solve it. So that will help us. So what I'm going to do, I'm just going to drop a perpendicular here. I'm also dropping a perpendicular over here like this. Okay, we will assume certain angles. I will just assume this angle as I, then this will be also I. Perfect. If this is I, this is I. Why? Laws of reflection. Okay, perfect. This is the first thing of my procedure. The next thing that I will do, I'm writing it in separate slides so that you can see the sequence of events. If this is I know one thing. This particular angle which you see over here will be how much, guys? This particular angle will be how much, guys? Because this is 90, this is I, obviously this will be 90 minus I angle. This will be nothing but 90 minus I angle. And if I call this as I1, this will be also I1 and this will be also I1. Same way, what I will do, if I mark this particular angle over here, this particular angle over here as I2, even this angle will be I2, and then this particular angle right over here will be 90 minus I2. You might be wondering, why are we doing this exactly? So that I can find a relationship between I1, I2 in the final steps. And why? can I find the relationship? Because they are angles, internal angles of a triangle. That's the thought process that I have used. So if you ask me, what is the total deviation of this? I can tell you one thing, that the total deviation is because of the mirror 1 and mirror 2. It's like saying mirror 1 deviated it by 5 degrees, mirror 2 deviated by 20 degrees. So what will be the total deviation? 5 degrees because of 1, 20 degrees because of 2. So 5 plus 20, which is 25. So you are just adding the angles of deviation to get the total deviation. Getting my point? Okay, I'm adding 5 degrees and 20 degrees. Okay, 25 degrees. Total deviation. Mirror 1, mirror 2. Each one is responsible equally. Okay. Now, delta 1 by formula, which we have just seen some time back right over here, is 180 minus 2 times the angle of incidence. So let me write it down right over here. Okay, so it will be 180 degrees minus 2 times of I1, that is delta 1, and delta 2 will be 180 minus 2 times of the second angle of incidence. 180 and 180 together will make it 360, and we will have 2 common, and we'll have I1 and I2, both of them together. Now the problem is to somehow get rid of this I1 and I2. And how do I do that? Look at this beautiful triangle right over here. Okay, look at this beautiful triangle which is there right over here. In that particular triangle, can I say the sum of angles of a triangle are 180 degrees? So theta plus 90 minus I1 plus 90 minus I2 is 180 degrees. Therefore, theta is there. 90 and 90 will make it 180. I1 and I2, I will take it on the other side. So it will become I1 plus I2. 180, 180 will cancel. So theta will become I1 plus I2. That's exactly what I wanted. I1 plus I2 is nothing but 2 times of theta. And the best part is we have got the answer, which you can see is independent of angle of incidence 1 or angle of incidence 2. It is not dependent on that. It is just 360 minus 2 theta. Brilliant. Okay. Amazing. All right. Puma, the syllabus will be completed in the next couple of weeks, 1 or 2 months. That's it. We are almost coming to the end. Ray optics, wave optics, then modern physics, AC is there. I mean, what else is there now? Yeah, very close to the end. Okay, thank you, Sangam. Great, great. Okay. No, this is a complete independent chapter. You should have good understanding of geometry and in general visualization for this chapter. Other than that, you don't need much. Like vectors is probably mandatory because vectors improves your visualization in the initial phases. Okay, now that we have understood how do we trace the rays, let's talk about plane mirrors and their properties. Now, whenever you take a plane mirror, the rays which fall on it will reflect following the laws of reflection. But the image which is formed by it has some properties which it follows. And let's see all of them one by one. First thing, if you take an object, that means you make somebody stand or you place something in front of a plane mirror, we know the image is formed behind the mirror. Like you take a selfie or you are in front of a mirror combing your hair or you are at a barber shop, you would have seen your image in front of a plane mirror. So you see yourself here and this is the image which is behind the mirror. So you will see that always if this is the object distance, and this particular thing is image distance, how far behind the mirror is the image formed, they both are always going to be equal. Object distance and image distance for a plane mirror, they will always be equal. It follows the laws of simple geometry and laws of reflection. This ray will deviate like this ray will deviate like this, and the image is formed behind. Not just that, you will see that this image being behind the mirror is then a virtual image. A virtual image. This is a virtual image. This particular object right over here is a real object. Real object. Now, what is the meaning of virtual and real? Okay, simple guys. I'll tell you what. If it is actually meeting or actually coming, then that ray, wherever it is coming out from or meeting at, that represents a real object or a real image. Like, is the ray actually coming out of the object? Yes, definitely it is real. Is the ray actually meeting here? No, you had to extend it. You had to extend it. Imaginary, it was visualization. You had to geometrically construct. It was imaginary. They were meeting. Actually, they were never going to meet. Just because you retraced it back behind, they are meeting. That is why it is virtual image. Got my point, everyone? The difference between real and virtual. But a lot of people say that plane mirrors always produce virtual image. That concept is also wrong. I'll tell you why. Imagine somebody decides to take again a mirror like this. Okay. You draw. This is the silvered face behind of it. Second. This is your silvered face. This is that actual mirror behind it. Okay. Now, imagine you have a virtual object. Okay, how virtual objects are formed, we'll think about it later. Imagine this is a virtual object. What is the meaning of virtual object? Imagine something like, maybe there is a real object over here. There is a real object over here. Somebody was holding a magnifying glass. So the rays went like this and they were about to meet over here. But before they met, you placed a mirror. So this magnifying glass would have formed an image here, but before it actually met, you cut short the journey of the rays by placing a mirror. So the rays are not actually meeting, because if they actually met, it would be real. You are cutting it short. You have to extend the rays. So whenever you have to imagine, imaginary, it is virtual. Got my point? So that is the reason why this is now a virtual object. It is now a virtual object. Did you understand the concept of a virtual object? Where the rays were supposed to meet somewhere here, but you have cut short the journey. You have cut short the journey by placing a mirror in front. So in such scenarios, you will see something like this. Maybe this is a virtual object. So the rays were cut short. So if you extend them, you can figure out where they would meet. Wherever they meet, that is the location of that object, but this is now virtual because you have not actually made the rays meet. It is an imaginary meeting of the rays. And then, Puma, the playlist will be updated. We got your chat. Okay, don't spam. Okay, don't worry. Then the rays will get reflected from here. The rays will get obviously reflected from here. And once they get reflected, okay, incident angle is reflected angle. Again, incident angle is reflected angle. Do you see they are actually meeting somewhere again? See, both these rays after reflection, this is going like this. This is going like this. They are actually meeting somewhere. So if they are actually meeting at some place, what image is this? This is a real image. So a plane mirror can form a virtual image for a real object, and it can form a real image for a virtual object. Is that clear? How many of you did not know about this? How many of you did not know about this? This can be a statement-based question in JEE Mains. Okay, a plane mirror always forms virtual image. True, false kind. Okay, maybe statement-based, assertion, reason, something like that. Or maybe even in match the following, anything. Answer will be no. It can make real image also. It can make virtual image also, both. Clear? Okay. Deepan Raj, I already mentioned at least 6 classes will go. All right. Perfect. Okay. Great. Now that we understood how that image is formed and we understood, okay, it is a virtual or real. The next important thing is the size of that image which is formed. Okay, that is also called as magnification. So if I'm standing in front of the mirror, obviously the same size image is formed behind me, because for this point the image will be formed here, for this point the image will be formed here, for this point image will be formed here. So you will see an exact replica of me behind the mirror. So you will say that the size of the object is equal to the size of the image, whether it is width, height, length, whatever you take, it is the same thing. So in such a case, I will say the magnification, can you guess what will the magnification M will be? How many times has it been magnified? 1. 1 represents unity, means it has not been enlarged nor been diminished. It's of the same size. If this magnification was 2, 3, 10, something like that, that means you have enlarged it. If this same number was like 0.9, 0.65 or 0.1, that means you have made the image smaller than the original object. That's what this number magnification tells. Okay. Okay, perfect. Amazing, amazing. Great. I'm very good, Agnes. Thank you so much. Can we see a real image? Can we see a virtual image? Okay, answer that question. Can you see a virtual image? Obviously. Everybody has seen a virtual image. Like you stand in front of a mirror, you will see it. You take a spoon, you can see your virtual image. You take a magnifying glass and you zoom onto something, you will see an image being formed. Okay, of whatever bacteria, virus, hair, whatever you are seeing under that microscope or the magnifying glass, that is again virtual. Real means the rays should meet. Now, when they meet at some point, if you have some smoke or some screen, on that screen, that image can be seen. So, for a real image to be observed, real image will be anyways formed, whether you put a screen or not. But for you to see it, you will need a screen on the place where the real image is formed, where the rays are meeting. Best example, projector or a cinema theater. You will see some rays are coming from behind of you from the projector, or in the cinema theater there is a reel, and the rays will meet on the screen of the theater, or your classroom will have a whiteboard where the rays will meet. So that is a real image. Imagine there was no screen in front. You just take the projector. Where will you see whatever the rays are meeting? There is no place there. So you will need the rays to meet at a place and a screen at that meeting place for the real image to be seen. Got it? Perfecto. Moving ahead, the last part is where the image form is always laterally inverted. This is a very amazing question. Lateral inversion. A lot of people think lateral inversion means, sir, my left will become right, sir, and my right will become left. In a way, you're right. Okay. If I was a right-handed person, in reality, my image will be a left-handed person. So just imagine now, two Shreyas. I wish there was some animation maybe in the future which would do it in a live class. Imagine Shreyas Sir drawing something over here. Imagine there is some mirror over here. Imagine you seeing my mirror image like this. At the same time, I will be using my left hand. My virtual Shreyas Sir will be using left hand. If the virtual Shreyas Sir lifts his right hand, then the real Shreyas Sir will lift the left hand. So that is what lateral inversion is in simple explanation. But the real explanation is, what lateral inversion does is, if you draw perpendicular to the mirror, it pulls that object inside out. Just think of me. I've been pulled. Think of some ghost-like thing, some animation, fluidic stressor being pulled inside out. So my nose is coming here. My head is behind. My back part of this head, the hair is also being pulled, and it will be formed as an image behind of me. My nose will come here. My hair here will go here. So that's why you will see a laterally inverted image. So it is being as if somebody has pulled me inside out. That is lateral inversion. Is that clear? So multiple things. There is same distance between the object and the image, right? Both kinds of images can be formed, virtual or real. The magnification is one, same size as the object, and it is also laterally inverted. It is also laterally inverted. Perfect. Okay. All right. Now, having said that, maybe we can solve a question coming up on your screen. Here it is. The light rays from an object have been reflected towards an observer from a standard flat mirror. The image observed by the observer are light rays from an object have been reflected. Is it real? Is it erect? Is it smaller in size than the object? Is it lateral inverted? What do you think? It's kind of obvious. If there are light rays which are falling onto a mirror, what will happen? It will be reflected, right? Something like this. And maybe you will see an image like this over here. This is going to be virtual image behind. It can't be real for sure. It will not be real. It will be smaller. No. It will be laterally inverted. It will be erect. That is also true. You can see whatever this image is, if the person is standing like this, the image is also erect. So yes, this is also a very important thing, that the image is always going to be erect. Inverted means you are standing like this, the image is upside down. Or if you are upside down, the image is straight. So it is being inverted. But it is not being inverted, it is always going to be erect. So I think it should be B and D. So B and D is there in option 1. So option 1 is the right answer. Imagine this was asked in JEE 2023 for a plane mirror. Yeah, very good, Rohit, Rama. Amazing. Thank you so much, Sangeem. Yes, perfecto, perfecto. Amazing. Let's move. Let's move now to the next concept in the plane mirror, which is where again you might find couple of questions, which is field of view. Now, imagine I have the moon and the night sky, and I ask you, I want to see the moon in my mirror. What do you think? What should be the size of the mirror that will be needed? How much radius of the mirror will be needed if I take a circular mirror to see the moon? Will it be the size of my eyeball? Should it be the size of the moon? Should it be half the size of the moon? To see the moon completely inside the mirror. Right now, there is moon, let's say, in the night sky. I want to see the moon's reflection in the mirror. What is the bare minimum size or the radius of the mirror that is needed for me to see the moon? Will it be the size of my eyeball, the radius, or should it be the size of the radius of the moon itself, or should it be half the size of the moon which is needed, or is it something else? It could be very small also. H by 2. Oh, is it really? I'll tell you what. The answer is you will need much smaller mirror, even this smaller. See, if you think about the moon is very far. By the time its image will be formed inside the mirror, the image will be very far, deep inside the mirror. The moon will be very far inside that mirror. You will barely need this much size of the mirror. A very small mirror is enough to see the moon. How can it be half the size of the moon? Are you serious? The moon is so big, and you are saying h by 2. H by 2, that means what? Some 100-200 kilometers we will need of mirror. I don't think so. I think I can just take a mirror of palm size of mine, and I will be able to definitely see that moon. I can guarantee you that. If you don't believe me, go outside and see it right away, right now. So it doesn't. I don't know why you are saying h by 2, because you have some I don't know, some random pre-lecture notions which are there. It is definitely not h by 2. So there comes the concept of field of view. So what is the meaning of field of view? See guys, if there is some object I have placed over here. The rays will go in multiple directions. And let me show some of those rays. The rays will go in multiple directions. Some of the rays will go like this. Some of the rays will go like this. Some of the rays will go like this. Some of the rays will also go here. Some of the rays will also go here. And all these rays will get reflected. All these rays will get reflected. All these rays are getting reflected, as you can see. Now, as they get reflected, I can extend them back and I can retrace back where that image is, like you can see over here. But think about this particular ray. The ray which is going here, it is not encountering only any mirror. So that ray will just go like this. Okay? Or that ray here will also go like this. That ray will also go like this. This ray will just go like this. So this will all be not reflected. They are all not reflected by the mirror. So you cannot see any image due to the reflection. So what this means is, this particular zone that you see, right from here till here, this zone is where you can see the image inside the mirror. You can try it out with a simple mirror if you have any, okay? Or even the phone surface also acts like a mirror sometimes. Imagine, or you can take a selfie camera or something like that, or just turn off the phone so that it acts like a mirror. It has some coating so it reflects. Imagine you place a pen over here. This is my object, and see where and all can I see the pen. Here I can see, here I can see. Now I cannot see. Now I can't see because the rays are not getting reflected and coming into my eye. The rays are directly going somewhere. If I go here also, I can't see. Only in few places I can see this particular object. Just try it out and give me a thumbs up with a mirror or a phone's reflecting surface. Yep. How many of you are able to see that in action? Let me know quickly in the chat box. Let me know quickly in the chat box, guys. Just take a plain mirror or something. Now, this is actually not a plain mirror, unfortunately. Okay, this is not a plain mirror. Just take a plain mirror and just try it out. You will see that if I have an object over here and I won't be able to see it beyond a certain point up and below, only in a certain region. So, only in certain region I can say this is the field of view, but this zone is a dead zone. Dead zone, dead zone, dead zone, field of view, field of view, field of view, field of view, field of view. I can see it in my field of view. Getting my point, everyone? So this particular zone over here that you see is your field of view. The rest all places are then dead zone. No view, no reflected view. You can still see the object, but no reflected view. Is that clear, everyone? What is the meaning of field of view? Cool? Amazing. So many of you saw it right now. Also, think of it. The size of the mirror matters in my field of view. If my mirror was smaller, my field of view will be less. If my mirror was bigger, my field of view will naturally be higher, because if my mirror is able to capture more and more rays, my view will become big. So I'll be able to see it from many places. But if the mirror becomes smaller, then I'm limiting my field of view and increasing my dead zone. You can say that. So for capturing the field of view or dead zone geometrically, just draw the extreme rays, and most of the times you will be getting the answer by using simple rules. Okay, that's the easy way. I will show you one more example of field of view. Look at this. There is this eye, there is this person who is standing. This person has to see this person through this mirror. So again, the concept of field of view, guys, you can see the extreme rays should be somehow be able to reach the eye. So the ray from the head should be able to reach the eye. The ray from the toe should be able to reach the eye. If both the toe ray and the head ray is able to reach the eye, then that is the field of view. But you know what? I have another view of this. to explain this. Nobody, I have not seen many teachers doing that, especially on YouTube. Maybe somewhere in offline or online, they might be doing it. But I'll give you a completely different way of looking at mirrors. And that is going to change the way you look at mirrors. It might scare you also. So imagine there is a Pandu over here. Imagine there is a Pandu over here. And Pandu has been granted a new wish. Pandu has been granted a new wish. And that wish is something like this. He has been given a magical portal, like you have portals to go to different multiple universe. This is a magical portal in front of him. And in that portal, he sees a new world which is identical to his. Which is identical to his. The only difference is everything is happening as so. But if there is a right-handed person here, that person is left-handed over here. So he sees a new world which is identical to his world, but which is mirrored or laterally inverted. So this is your portal. This is your portal, and this is reality. This is reality. This is reality, and this is laterally inverted virtual world. So think of a mirror as a magical portal which opens up to a virtual world which is laterally inverted. And that is like a window. It is like a window, a portal like a window. Now think about it. If that window, if you have a window in front of you, if that window is small, you barely can see what is there outside. If that window is big, you can see many things on the other side. Where that window is decides which part of the world you can see. Getting my point? Everybody with me? Understanding the concept? Agree? Same way, imagine, forget this. Imagine there is a Pandu over here. Imagine there is a Pandu over here. And there is a mirror over here. Mirror is very big, h by 2, h by 3, h, 2h, whatever you want, you take. But the mirror is not directly in front of him. Can the Pandu see his reflection? Yes or no? Quickly answer in the chat box. Can the Pandu see himself in the mirror? Yes or no? Answer in the chat box. What you should do? Think of the mirror like a portal where everything is identical but laterally inverted. So there is another Pandu in this virtual world who is laterally inverted. Imagine now a window which is there on the top and you are below. And there is another Pandu, there is a wall in between. Now think of this like a wall. Think of this like a wall. Can this Pandu see this Pandu's image? Obviously not, because there is a wall. But if you bring this mirror down, he will be able to see himself. Getting my point? How many of you understood this concept now? What is the meaning of this virtual world, portal, window? Crazy, right? Idea. So this makes things very clear that if that window was magically brought down, you will be able to see your reflection. You will be able to see yourself in the virtual world. But if you bring that window on the top, there is a opaque screen or something like a wall, which you will not be able to see the virtual world's Pandu. Perfect. So with this, let's use that concept to solve this question, and then I will make you solve a more complex question. Okay, this is a laddu question. Everybody will be able to give it directly because maybe you have by hearted the answer. Minimum length of the plane mirror required to observe the height of H to see himself. So often you are wearing some nice shoes, you are wearing a great tie, you are wearing a suit, you have combed your hair nicely, and you want to see yourself and capture yourself in the mirror. So what's the minimum height of the image? What is the minimum height of the mirror needed to capture yourself or to see yourself in the mirror? That is the question. Because obviously I can't use this mirror to see myself. I can see my face, I can see my chest, I can see my toe, but I can't see my whole self. I will need a bigger mirror for sure. So what's the concept over here? Here is what we'll do. Right now, I will say let the mirror size required be infinite, or I will take an infinitely big mirror, and then I will cut in that mirror which is not needed. Okay, so let's say our Pandu is over here. This is our Pandu. So the virtual Pandu will be over here, exactly at the same distance behind the mirror. Okay, something like this. Hopefully it is of the same size, not just assume it is. So this is my object of height h, and this is my image of the same height h, of course. Now imagine the eyes of this particular Pandu are here. So if this Pandu has to see his image and the rays will go through a virtual window, think of the rays going like this into his eyes. Think of the rays going like this into his eyes. So how much window will be needed now? It is obvious. Only this much window is needed. This much window is needed. Rest of the window is not needed. Yes or no? Yes or no? This much window is not needed anymore because those rays will anyways be blocked and it is not entering my eye. Right now I'm able to capture the head, I'm able to capture the toe. That is enough for me. So this is the mirror which will then be needed. This is the mirror which will then be needed. How many of you understood this concept of virtual window, how I have used it? Yeah. So now these are just two triangles which are identical to each other. I hope you are able to see that. Yeah. There is one triangle like this and one triangle which is like this. The base of this triangle is this one, which is height h, and the base of the other triangle is this particular mirror over here. Okay. These are two similar triangles. Why similar triangles? Angles are same, right? Obviously. Not just that, think of it like this. If this much is x, obvio, this is also going to be x. Image distance, object distance are going to be the same. So it is now very, very obvious to all of you that if this much is x, this much is obviously 2x. 2x. If this is x, this much is 2x. So if this is h, obviously this will be h by 2. Isn't it obvious now? The triangle sides, altitudes, medians, everything will be in the same ratio. So if the ratio is 1 is to 2, this will be also 1 is to 2. If this is half is to 1, this will be also half is to 1. 3 is to 1, 3 is to 1. So if this is h, this will be half of that, which is h by 2. Hence option B. Clear? How we solved it using the virtual portal, which I explained to you. This virtual portal window concept is very, very useful. I will give you more such examples right over here, right now. There is an elephant. There is an elephant standing over here. Okay, there is an elephant standing over here. I hope it looks like an elephant. The elephant's height is h. The elephant's height is basically h. Then what happens is on the ground, at some distance, there is a Pandu who is standing over here. There is a Pandu who is standing over here, and this Pandu from the front of the elephant is standing at a distance of h. In front of him, there is a mirror again at a distance of h. Again, a mirror which is at a distance of h, like this. Now, the question is to figure out. I do not know how much mirror will be needed. You can place the mirror wherever you want. The question is find the minimum size of the mirror to see the elephant. Okay, that is the question. He just wants to see the tusk and the front face. Don't say, sir, I cannot see the back part or the tail of the elephant and all. Okay, ignore when we just want to see the front of the elephant. Okay. So question is, what is the bare minimum size of the mirror which is needed? Always do what? Make the mirror like a portal and make a virtual world. Simple logic. Okay. So let's open up our portal, guys. Magical wand. Okay. And that magical wand is going to open up that portal to a new universe which looks exactly similar to ours, but it is laterally inverted. Okay, that portal is somewhere here. Right now I'm not showing, but I will also show the elephant's image. So the elephant's image will be here. Okay, this is our elephant. Where is that elephant? This is the image of the elephant. This is H, this much. This is image of elephant. This is the image of our elephant. Now our portal will be somewhere over here. I do not know how much of that portal will be needed. So I'm just drawing one line. If you want to see the elephant in the virtual world, the rays should finally enter my eye. So let me show the extreme rays from the top entering my eye and from the toe also entering my eye. It is now very obvious how much mirror is needed. It is obviously this much. The remaining part of the mirror, like this one over here and this one over here, is obviously not needed. But bear in mind certain things. This much is H. So, okay, this much is H. Where is the elephant going to be? Do not forget, the elephant was actually at a distance of 2H. Okay, elephant was at a distance of 2H. So the image of the elephant behind the mirror will also be at a distance of 2H. How many of you were able to figure this out? This is basically 2 times of H. This is the object. This is my object. The image will be formed 2H distance behind the mirror. Everybody with me? This is that mirror which will be needed. Now it's just a matter of similarity of triangles. It is not h by 2. Many of you made that same mistake again. Now again it's a matter of similarity of triangles, my dear warriors. So let's use similarity of triangles now. That is the concept which I will be needing. One triangle, as you can see, is like this, and the other triangle is little bit longer, like this. Okay, this triangle, smaller one, has a base of the mirror. The other larger triangle has the base of the height of that elephant. Okay, so this is H, and I do not know how much is this. So what is this one? This one is obviously H. Can you guess the height of this larger triangle? Large triangle, 2H and H. How much is this entire height? Obviously, that is going to be 3H. So this is 3H. Can you see that? Similarity of triangles. So if this is 1, this is 3. If this is H, this is 3H. So if this is H, this will be H by 3. 1/3 of it. This is 3, this is 1. This is 3H, this is H. This is X, this will be X by 3. If this is H, this will be H by 3. So therefore, the minimum size which will be needed will be H by 3, and you'll be placing the mirror somewhere here so that you can see the image of the elephant behind of you. Got it? How many of you loved this concept of portal? How many of you loved this concept of portal? Is it not making the problem simple? It's not just H by 2 question. H by 2 question will not come in the exam most likely because it is very common and everybody will solve it. No. So this kind of questions can come where some other object is there. You are looking at some other object. You are standing at some weird distance. What size of the mirror is needed? So those kind of questions for field of view might come. Crystal clear. Very good. Amazing. Keep smashing that like button in case you haven't done that yet. Okay. So now we will move to this particular concept of speed of the image and speed of the object and all of that kind of questions. Okay. So this particular concept, let me explain this to you. It's not really a theory. Sorry, question. So the concept of motion of object and mirror. What if our mirror or the object, both or one of them moves? Then what are we supposed to really do? Okay, I will give you a couple of scenarios and then figure out one by one what is exactly going to happen. So let's take the first scenario right over here, where say this is the mirror. Okay, this is again the mirror. Okay, over here. Okay, duplicate this. Say there is an object over here which is coming towards the mirror with a speed of 4 meters per second. Let's say there is an object over here which is moving like this with a speed of 5 meters per second. Then here we have an object which goes like this at a speed of 4 meters per second. Then we have the object at rest, but this mirror is going up at some speed of, let's say, 7 meters per second. Then we will take the scenario where our object is at rest, but it is this mirror which is moving at 3 meters per second. And finally, there is an object over here, and this mirror is moving towards the object at 5 meters per second. In each case, I want to know what that image is going to do. I want to know where on earth is this image going to move and with what speed, if at all, it is moving. Okay, that is the question. Let's try to figure it out in every single scenario using simple logic. Okay, let's understand. Mirror is at rest. Object moves closer. Imagine, just think, guys. There is this mirror. I am the object. Okay, this mirror is here. Okay, like this. And I am coming closer to the mirror. Where will the image move behind the mirror? Will it also go away? Imagine you are going close to the mirror and the image inside the mirror is running away from the mirror. You will get scared, man. You will freak out. You will lose your calm if the image went away from the mirror, because it will be like you are a ghost. Okay, you will feel something is wrong. You are whacked up in the head. So, my dear warriors, if you are moving towards the mirror, the image should also move towards you with obviously the same speed, not more nor less. If it is coming faster, that also will freak you out. Or if it is coming slower, you are moving like 100 meters per second and the image is moving at 1 meter per second, that is also going to freak you out. It's going to happen exactly at the same speed, because if I move 4 meters, image should also move 4 meters in that time. So obviously this should be 4 meters per second. The same logic also makes sense over here. If I am moving away from the mirror, the reflection of mine behind the mirror will also try to move away. So my object distance increases, my image distance also increases at the same rate. So I will be moving at 5 meters per second. Is that right, everyone? Yep, perfecto. How about this scenario? I am moving like this. Where will the image move? Interesting. So imagine there is an object here in front of the mirror. The object goes up. Where will the image behind the mirror go? If you have a mirror in front of you right now, or a reflecting surface, just try it out. Object goes up, the image behind should not go down. Don't say, sir, it will go opposite. Imagine you are moving a pen or that object up, the image goes down, you will be like, what? What the hell is happening? The image should also go up at the same place, same pace, sorry. Yes, it should go up like this at 4 meters per second. Perfect. What happens if the mirror in front of you moves? Wow, crazy. Yes, I'm just standing. The mirror just goes up. Mirror just goes up. Just move the mirror in front of you. Can you see what is happening? you are still going to be there. I mean, your reflection will be here. That reflection won't change. Let the mirror go up and down, not front back. That is different. I'm just saying up and down like this. So yes, definitely there will be no change at all. So this image will be at rest if assuming this object was also at rest. Oh yeah, correct everyone. What about this scenario? My mirror itself is moving. Crazy. So let's look at it from the mirror's perspective. If you sit on the mirror right now at that moment, because the mirror is moving away from you, the mirror will feel the object is moving away at 3 meters per second. So if the mirror feels the object is going like this, the image for the mirror will move like this at 3 meters per second. This is from the mirror frame of reference. Mirror frame of reference, if I take it. Mirror frame of reference. Oh, so for the mirror, the image is moving 3 meters per second. But do not forget, the mirror itself is moving at 3 meters per second. So for the mirror, the image is going at 3 and the mirror is also going at 3. So both the speeds will add up and you will end up seeing a net speed of 6 meters per second. This 3 and this 3. For the mirror, the image moves at 3 meters per second, but the mirror itself is moving, so it will move with faster speed for the ground frame. Got it, everyone? Yes, Rohit, that's absolutely correct. How about this scenario? The logic is again the same. If you look at it from the mirror perspective, the mirror is coming close to the object. So the object will come close to the mirror at the same speed. Hence, the image will go like this at the same speed for the mirror perspective. So now think, for the mirror, the image is coming like this, but the mirror itself is going at 5. Mirror is going at 5 and for the mirror, the image is further moving at 5. So the speed will double up and it will become how much? Obviously, 10 meters per second. Clear now, everyone? Yep, perfect. So from this, can we make a generic rule or something like that? The answer is yes. And then we can solve any kind of question given to me. And the rule is as follows. If you have a mirror, like this, then the object can have two kinds of velocities. One is like this, VO, which is perpendicular, okay, in the perpendicular direction, and it can also have a velocity like this in the parallel direction. Let's just talk about perpendicular direction first, and then we can also deal with what happens in the parallel direction. Parallel is very, very easy. Velocity of the object parallel to the mirror. Here now we are talking about perpendicular direction. Perpendicular. This is perpendicular direction. And the next one we'll talk about parallel direction. In either case, let's say this is the velocity of the mirror in the parallel direction. Here, let's say this is velocity of the mirror in the perpendicular direction. The image will have some kind of velocity. I'll call it Vi. Here, here I will also call image will have some kind of velocity Vi. This is very easy. This velocity of the mirror will not matter only in this case. What matters is VO. So you will see Vi bar will be equal to VO bar. This is only in the parallel direction. Okay, very, very important. This is along the parallel direction of the mirror. Okay, these are those components. But if you take perpendicular components, then I'll tell you one thing. Use the relative velocity concept. The velocity of the object with respect to the mirror is equal to velocity of the image with respect to the mirror, but in the opposite direction. This is the best example for it. The velocity of the object is 4 I cap. Velocity of the image is minus 4 I cap. Velocity of the object is minus 5. Velocity of the image is plus 5, all with respect to the mirror. Not just this scenario, even this scenario. If you take the mirror frame, if this is plus 3, this is minus 3. If this is plus 5, this is minus 5. So with respect to the mirror, they are equal, but they are opposite to each other. Is this absolutely clear? So what is VIM then? What is VIM by vector relative equation? It is VIM is VI minus VM. Is that right? Absolutely. Same thing over here. This will be nothing but VO vector minus VM vector minus Vm vector. Solve this. I think you are going to get the answer now. Solve this. You are going to get the answer now. So we want basically Vi. Okay, we want basically Vi. This is minus Vi. Minus Vi comes on this side. It will become plus Vi vector is equal to. Look at this minus Vm. This minus Vm. 2 times it will come. This minus Vm will become plus Vm. And this minus minus will also become plus Vm. And this VO on the other side will become minus VO vector. So therefore, I will get VI vector is nothing but 2 times of Vm vector minus VO vector. This is again a very important relationship. This formula is very easy, nothing great. This is the main formula when things are perpendicular to the mirror. Vi is 2Vm minus Vo. Vi is 2Vm minus Vo. Okay, perfect. Remember this equation. Now, let's solve the problems using this equation and you will see how easy it is to solve the questions. Imagine there is one object here. It has a velocity of 3 meters per second. Imagine there is an object over here. It has a velocity of 5 meters per second. Imagine this particular mirror has a speed of 7 meters per second. Imagine this mirror has a velocity of 2 meters per second like this, and also a velocity of 5, or let's say 6 meters per second like this. I want to see where the image is going to be. I want to see what that image is going to do. So in this particular scenario, if I want to see what that image is going to do, look at it. Vi will be 2 times of, use this formula. Vi is nothing but 2Vm minus Vo. 2Vm minus Vo. 2 times of Vm. Vm is 7 minus Vo, which is 3. 7 2s are 14. 14 minus 3 is 11. 11 meters per second. Because it is positive, that means it will be in this side. If it was negative, automatically it is on the other side. This 2 will have no effect at all. This 5 will ensure that in the parallel direction, the speed will still be the same. So, only thing is that perpendicular direction. So, Vi will be 2 times of Vm. Vm is 6 minus Vo. Vo is 0 in the horizontal direction. So, 2 6 are 12. So, this perpendicular direction speed will be 12 meters per second. So, it will have two components, 5 also and 12 also. So, it will have a net speed then. Is this absolutely clear? Everyone? Let's solve more questions just so that you get a hang of it. More questions coming up on your screen. Again, there is a mirror and it is going like this at a speed of 4 meters per second. And then you have this particular object which is going like this at a speed of 10 meters per second. What will the image be doing? Vi will be 2 times Vm. Vm is minus 4, mind it, negative side, minus Vo, which is 10. So this will be minus 8 minus 10, which will be minus 18 meters per second. That means the image will go like this at a speed of 18 meters per second. So easy it is to solve the questions. Now, any kind of question will come, you will be able to solve it. So be careful. The negative sign is very important. Let's solve one more question coming up on your screen. Here it is. Imagine this mirror is again here like this. Okay, it is going with a speed of 6 meters per second, and there is an object over here going like this at a speed of 2 meters per second. What is that image going to do? Vi is 2 times Vm. Vm is negative minus 6 minus Vo. Vo is also negative. Can you see? It is also negative. So it will be minus 12 plus 2. So this will be minus 10 meters per second. Minus 10 means like this. So it will move at a speed of 10 meters per second. So it becomes very easy peasy, lemon squeezy to solve the problem. Okay, everyone? Simple, easy peasy, lemon squeezy using this formulas. What is that formula? This one, 2Vm minus Vo in the perpendicular direction. For parallel, though, there is nothing. Whatever is the speed of the object, same speed it will go. Vm will not come only in that. Great. So, I think these questions you will be able to solve very easily now. Speed of the image. Object goes 1 centimeter, image goes this 1 centimeter. Object goes like this, image will go how much? We can solve it very easily. Vi will be 2 times Vm. Vm is 2 minus Vo, which is 1. 2 2s are 4. 4 minus 1, 3. So it will move 3 centimeters. So this image will move 3 centimeters directly. Very easy to solve the questions now. Okay. Now let's look at the next concept, which is the concept of parallel mirrors and multiple mirrors, and then we'll go to inclined mirrors also. You might have faced this scenario when you are at a saloon or maybe in a changing room in a in a cloth shop. Okay, or you're going to buy some dress or shirt or whatever, and you are trying it out, and there is a mirror in the front, there is a mirror at the back, and you see multiple images of yours. Have you seen this? How many of you seen this yourself? Tell me in the chat box. Dual nature, there is still some time. How many of you have faced this, seen this in real life? Infinite images, yes, Rohit, correct. You have, Rama. Okay. Very good. Many of you have seen it. Great, great, great. Very good, guys. Very good. So, why is there infinite images? And why is there multiple images at all? What happens is, imagine this object is there. There is one mirror. This object will reflect in this mirror and will form an image behind. Okay? So, you are seeing yourself. Same way this object's image is formed behind the mirror. You can see that right over here. You can see there is an image formed. Can you see that in this particular mirror? Now, this image behind that mirror, okay, this image behind that mirror will act like an object for the mirror behind me. There are two mirrors. One is here and one is here. So, if there is an object here, that reflection image will be formed here. This image will be an object for this mirror, and in that mirror, you will see the reflection behind. That image will become the object for this mirror, again forming an image here. So like that, it will happen infinite number of times. That's why you will see infinite such images. Getting my point? Why this will happen? Because you will have two parallel mirrors. You are stuck between two parallel mirrors. You will be reflected here. That image will now become object for this. So there will be an image there. That image will become an object for this. It will again reflect there. That image will again become an object for this. Again reflect there. That will keep on continuing. Tuck, 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 tuck. But every reflection, the rays will spread. Some rays will get absorbed, diffused, etc. So what will happen to the next and next and next image? They'll become more and more bright or faint. They'll become faint. So it's not like you can see all the infinite images. You can see they'll become blurry, not so bright. They are faded. So the images will definitely get faded, and after a threshold where your human eye cannot detect that brightness, you will not be able to see those infinite images. obviously it will be finite number of images because of the threshold limitation of your eyes and the diffusion and the spreading and absorption of light rays. Otherwise, ideally, if you had infinite perfect reflectors, you will see infinite images. Yeah. Yes, you can say that. Yes, every image will then become the object for the next mirror and next and next. Will it be the virtual object? The answer is no. It will still be a real object because the rays will, okay, actually feel like they are coming from a place. Okay, it will feel like a real object for that mirror. The mirror will feel, oh, there is actually an object over there. Okay. Now, Kamesh, next class is tomorrow only, my dear. So, what I can say, there are first of all, number one, infinite images. Number two, the brightness reduces after multiple reflections. After multiple reflections. Okay, brightness reduces. So, the logic for this is this object will give rays like this and reflect like that, maybe. Okay, so the first image could be formed here. Maybe this is the first image. That image will act like an object for this mirror and it will again create a reflection. So you can think as if another reflection will happen. So if you extend the ray behind, again that image number 2 will be formed. And the same thing can be said for a ray which goes to this side first. If it goes here, okay, it will be reflected like this, maybe. So if you extend it behind over here, this is where you will get the first image on this side. Okay. And again, that ray will get reflected here like this. And if you extend it behind over here, maybe you will get the next image over here, right? So like that, multiple reflections will keep on happening and you will get infinite number of images. Infinite number of images. Now, sir, how much rate it charges up to infinite? Meaning, I am not really sure what your question is, Rama. What rate, as in light does not travel straight line in black hole? Ayo, Spidey, where tangential questions you are going? Salome, welcome aboard. All right, Ananya, understood. Okay. Now, how do I locate these images? How do I locate these images? Let's take an example for this. Okay, simple example we'll take. We'll start off with, let's say, this is given to me. This is given to me maybe as, I don't know, 2 centimeters. Chumma random example. And let's say this is 3 centimeters. Random example I have taken. This is 2 centimeters in front of M1 and 3 centimeters in front of M2. I want to locate all the kinds of images which will be formed. The next 3-4 images or 2-3 images on this side also, and this side also. First, let's make the image because of M1 and then the successive reflections. Then I will also take the image which will be first formed due to M2 and then their successive reflections. Remember, rays are going on both sides. The first images will also be formed on both sides and the successive reflections will happen. So we need to consider both the scenarios. Due to mirror 1, first image, and due to mirror 2, first image, and then the second and the third and fourth. So let's start with mirror 1 first. If I am 2 centimeters in front of the mirror, the image will be formed obviously 2 centimeters behind. So I1 obviously will be 2 centimeters behind. Okay, this is the first step. Next step, this image will act like an object for this mirror. And as you can see, this is 2 plus 2, 4, 4 plus 3, 7. So if this is 7 centimeters behind. So 7 centimeters behind means somewhere over here. this is the next image which will be formed for this mirror. So this will be 7 centimeters. Check this out if this is absolutely clear. Okay, the first mirror reflected this object here. This image will now act like the object for this mirror, which is in front of it 7 centimeters. So the reflection will happen behind this mirror at 7 centimeters. The next step. This image will act like an object now for this mirror. How much is this thing? How much is this exactly? How much is this? 2 plus 3, 5, 5 plus 7, 12. So for this mirror, this object is 12 centimeters in front. So the image will be formed 12 centimeters behind. Okay, somewhere over here. So I'm just showing like this. So this is the third image which will be formed, which will be 12 centimeters behind this mirror. And again, this image will be the object for this mirror. And the next image will be formed. Okay, and you can keep on doing that. Everyone, till this point clear? We can keep on doing that on left, right, left, right, left, right. Wait a minute. We first took the reflection behind mirror 1. We did not take the reflection behind mirror 2 directly. Direct first reflection. So we will take that also and we'll superimpose both of them in the same diagram. This object is 3 centimeters is in front of mirror 2. So this object will reflect behind over here, and first image will be formed here at a distance of 3 centimeters behind mirror 2. This is 3 centimeters in front, 3 centimeters behind. Now that image becomes the object for this mirror. And how far is this? Just think, how far is this? How far is this? 3 plus 3, 6, 6 plus 2, 8 centimeters in front of this mirror. So this image, which is now going to act like an object for this mirror, will reflect behind at 8 centimeters. So you will see at 8 centimeters, the next reflection will happen. So this is going to be 8 centimeters. Next up, this image behind mirror 1 will act like an object for this. As you can see over here, this is 8, this is 2, 10 plus 3, 13. So this is 13 centimeters in front. This is 13 centimeters in front of this mirror. So the image will be formed 13 centimeters behind. So that is where the next image will be 13 centimeters behind. And then the next and next and next. That's it. So this is how the images are formed behind this mirror and this mirror. So if a question is asked, which is the second image behind mirror 1, then the answer will be 8 centimeters behind mirror 1. Okay, don't ignore this. This is formed as a result of multiple reflections. So this is the second image. If the question is which is the third image behind mirror number 2, the answer will be at a distance of 13 centimeters behind mirror 2. Got it? Saloni, tomorrow's topic will be curved mirrors, spherical mirrors. Okay, curved mirrors, spherical mirrors. That's what the topic is. So now, will you be able to solve quickly for anything? I hope this was very, very clear what we did over here. Starting off with this object being reflected here behind mirror 1. That reflected because of this mirror here. That again reflected here. And that will continue. Then we took this object's reflection behind this mirror first. Here. This image acts like an object for this mirror and reflects here. This image acts like an object for this mirror and reflects over there like that. That is how it continues. Okay. So no matter what you take, you will be able to do it. Let's say I'll do this quick now. Okay. Will not waste too much time. So let's say this is 10 centimeters and let's say this is 20 centimeters. Okay. How will the reflections be? Let's do it very quickly, guys. Come on, let's do 10. That means here, first image I1 at a distance of 10. This image will be the object for this mirror. 10 plus 10, 20 plus 20, 40. So 40 centimeters behind. So this will be I2. This will be 40 centimeters behind. This will be the object for this mirror. So 30 plus 40 is 70. So 70 centimeters behind. This will be I3 at a distance of 70 here. This will be the object for this mirror. 70 plus 10, 80, 80 plus 20, 100. So 100 centimeters in front. So 100 centimeters behind. So this will be I4 at a distance of 100 behind, like this. Now use the same logic for the reflection from the mirror number 2. We started off with mirror 1 first. So we are starting off with mirror 2 now. So 20 in front, so 20 behind. 20 in front, so 20 behind. So this will be I1. This will be 20, of course, like this. This image will act like an object for this mirror. So 20 plus 20, 40, 40 plus 10, 50. So 50 behind. So this will be I2. This will be 50, of course. This will act like an object for this guy. 50 plus 10 plus 20, which is 80. So 80 in front. So 80 behind. So somewhere over here. So this will be I3, which will be 80 centimeters behind. And again, you can take the reflection here. So this is 30 plus 80, which is 110. 110 in front, 110 behind. So this will be I4, which will be 110 behind, like this. So this is how multiple reflections will keep happening. Got it now? Everybody clear? It's very fun to do actually. Once you get the hang of it. Yeah, if you miss or if you don't concentrate and focus, then you will make a silly mistake. Chances are very high. That's why I said visualization is very much needed for this chapter, and concentration and focus is needed. If you lose, make a mistake, oh, which mirror's reflection was I taking? Gone. Doom. Okay. Now the last part of today's lecture, and that is multiple mirrors at an angle. So if you have been to a mall or to a clothing shop and there is a mirror on the door and mirror behind you, or maybe a barber or a saloon, mirror behind and mirror in the front. If it's holding perfectly flat, you will see infinite set of images like this. You will see infinite set of images like this. But if you turn the mirror, or this was a door, if you turn the door, you will see the mirrors go in an arc, one behind the other, but side displacing. They are as if in a curve. Have you noticed that? That is what you will see over here also. Yes. Imagine somebody has kept an object and there are two mirrors. You will see the mirrors will go in an arc and you will not see infinite images. You will see finite images, not infinite, finite. So in such cases, there will be finite number of images. Yes, after multiple reflections, the image gets dimmer, becomes dimmer and dimmer and dimmer. And lastly, the images are in a circle. The images are in a circle. This is very, very interesting. If you have flat mirrors like this, the images formed are here, 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 here. These are the images, and all these images, as you can see, they are on a straight line. These images are on a straight line. The moment you make the mirrors at an angle, remember our object was somewhere here, and this is that object, you will see the images will no longer be in a straight line. Rather, they will be in the form of a circle, something like this. Yes, beautiful, beautiful circle. So maybe one image could be here, 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 here. So there will be countable number of images. So they are going to be on a circle. And depending on the angle, whether it is small, big, etc., and where that object is placed, you will see the number of images will change. So the images are on a circle for inclined mirrors. For inclined mirrors. Is this understood, guys? How that image formation instead of a straight line? Now, the moment you turn that, that straight line becomes a curve, basically connected, and it is a circle now. So there will be finite number of points on that particular circle. Okay, perfect, amazing, amazing. You don't have to make short notes, my dear. Don't waste a time. That era is gone where you make short notes. Now is the time of smart notes. See, as technology advances, you have to change. During my times, we did not have this quick revision cards. People are using smart revision cards. Already notes are made. In this entire physics is there in this pocket. Huh? You can carry it while traveling in your school bus van. Carry it. It is beautifully arranged like this. So all concepts, formulas, theory, notes in smart cards. If you are going to sit and make notes now in September, all the best. You don't have that much time. Okay, so use this. The link is there in the description box of this particular video. It's called QR cards. Okay, perfect. So what's the formula, sir, for this? How many images are formed? There are 3 scenarios and there are only 2 formulas. What are the scenarios? Mirror 1 and mirror 2, theta is the angle between them. Okay, so 2 inclined mirrors, the angle between them is theta. The first step, what you will do is divide 360, if it is in degrees, by theta. Whatever answer you get, it could be 4, 5, anything. Let's say you get 4 or let's say you get 5. Chumma, I'm putting some random values. Okay. Now, if it is even integer, if it is even, which is even? The number 4. Then the number of images will be whatever answer you got minus 1. Forget whether symmetric or symmetric, minus 1. So the answer will be 3. If it is even, always make it kind of odd. Always kind of make it odd. Okay, 4 minus 1. Now, what is this symmetric and asymmetric? See, if I place the object on the angle bisector, it is symmetric. If this is the angle bisector, if I place the object here or very close to this mirror, it is asymmetric because more is there on this side, less is there on this side. So whether it is there on the angle bisector or not decides whether it is symmetric or asymmetric. So when it is even, it doesn't matter whether it lies on the angle bisector or does not lie on the angle bisector. The answer is that even number minus 1. So whatever that is. But the moment it becomes odd, then it matters. If it is symmetric, that means it is on the angle bisector, then do the same thing. So if it is 5, it is on the angle bisector, minus 1, so it will become 4. If it is not on the angle bisector, then leave it as it is. So then 5 only will be the answer. Okay, understood? So if it is odd number, only then check whether it is symmetric or asymmetric. So usually it is 360 by theta minus 1. When do you just take 360 by theta? When it is odd also and it is not symmetric. Only in that scenario, the answer is 360 by theta. Every other time, it is 360 by theta minus 1. Only when that 360 by theta is odd and it is asymmetrically placed, then the answer is 360 by theta. Okay, keep this in mind. So let's do some examples on this so that you get an idea and hang of it. Okay, say for example, this one only. Okay, there are 2 perpendicular mirrors and I have to find out how many images will be formed. This is my object. So to start off with, I'll first say the angle between the 2 mirrors. The angle between the two mirrors, theta, is obviously going to be 90 degrees. So first let me find 360 degrees by 90 degrees, which is 4, which is even. And the moment I have an even number, I don't care whether the object is asymmetric or symmetric. So the number of images will be that 4 minus 1. So it will be 3. And it is also true. It will be 3 because one image will be here, another image will be here, and the third image will be here. 1, 2, and 3. If you are wondering how, look at this. The two mirrors are perpendicular. One image is here, one image is here, and that reflection is there, which is the same thing. So 1, 2, and 3. 3 images are formed for perpendicular mirrors. Got it? 3 images. Okay. Santosh, I think it should start. Maybe give it a day. I'll just talk to Vipul sir again. All right. Now let's take another example, maybe this one over here, and see what the answer should be. Two mirrors are inclined at an angle of 30 degrees. An object is placed making 10 degrees. Find the total number of images. Okay, first do 360 degrees by 30 degrees. How much will it be, guys? It will be basically 12. 12 is an even number. The moment you get even, forget everything. The number of images will be that even number minus 1, which is 11. So 11 is the answer, which is D, I believe. Yes, it is D option. Perfecto. Got it? Everyone? Very good, very good, very good. Amazing, amazing. How about, let's say, the mirrors are, let's say, inclined at maybe 40 degrees, 40 degrees. And once the object is placed, here exactly at 20 degrees, second time the object is placed here, this is where the object is, at 10 degrees. How many number of images will be formed in both the scenarios? First things first, do 360 by theta, 360 by 40. So it will be 36 by 4, which is basically 9. Now 9 is an odd number. The moment it becomes odd, now you need to think. Same thing over here also. 360 degrees divided by 40 degrees, that is going to be 9, which is obviously an odd number. Now, what did I tell you about odd numbers? The moment it is odd, you need to check whether it is symmetric or not symmetric. If it is symmetric, it is minus 1. If it is not, just that number. As you can see, 20 degrees is exactly the middle of 40 degrees. So this is a symmetrical scenario. Symmetry is there. Symmetry is definitely there. So whenever there is symmetry, the number of images will be whatever answer you got, minus 1. So it will be 8. So in this case, it will be 8. But in this case, this is 10, this is 30. So it is non-symmetric. That symmetry is not there. So the number of images will be 360 by theta only. So the answer will be just 9. The answer will be just 9. Is this clear? Okay. Even if you take obtuse angle also, you will get the same thing, my dear. Like, say, for example, this and this. Okay. Say this particular angle is 120 degrees. And maybe somebody decided to place an object over here, maybe at an angle of 60 degrees. It could be something else also. First things first, do 360 divided by angle, which is 120, which is 3. Now 3 is an odd number, so you need to be careful. Why? Because whether it is symmetric or not. As you can see, 60 degrees is symmetry. Symmetry is there. The moment symmetry is there, the number of images will be this minus 1. So 2 images will be there. So one image might be here, one image will be here behind the mirrors. That's it. The answer is 2. Got it? Everyone? Sir, should I use a guide for CBSE board? Definitely, Ananya. Please use. Definitely you should use. You cannot depend on NCERT and school notes or class notes or teacher notes. Definitely not. Please go for a kind of guidebook apart from the PYQ book. Sometimes the guidebook itself has PYQs, that is good. Or if you have a separate guidebook, that is also perfectly fine. Okay, so this is how you do this. Now there is a homework question which I have kept, but there is a small thing. The distance between the images closest to the object should be there. Closest to the object thus formed is. Okay, so this is a previous year question. Just one small phrase I have added so that it becomes very clear. So there are two mirrors perpendicular to each other, so multiple reflections will happen. So what is the distance between the two images which are closest to the object? Okay, that is the question. So try it out. It's not that difficult. You will definitely get it. Okay, answer is there, solution is there on the next slide. So just try it out. Okay, all right. I hope you enjoyed the class and I hope you got a very good idea about plane mirror reflection. This lecture is one of the best lectures which you can find on the internet, YouTube, for plane mirrors. And same thing will come for curved mirrors and lenses and curved surface refraction and everything. Okay, in detail, every single type of question has been done, every single concept, every single formula for plane mirrors. And same thing we'll do for the remaining parts. Okay, stay tuned on the channel by subscribing and liking the video. Bye bye. Take care.